Now to the composition of the Jovian planets. All of the Jovian planets actually have relatively low densities. So Jupiter has a density of around 1,330 kilograms per meter cubed, and Saturn is at 690 kilograms per meter cubed. On this scale, using kilograms per meter cubed, water has a density of 1,000. So both of these are comparable to water. Jupiter is just slightly more dense than water. Saturn is slightly less dense than water. Because of these low densities, this suggests that they cannot be made of rock and iron. If they were, they'd have much, much higher densities. So instead, they have to be made of very, very light elements, particularly hydrogen and helium. Now, although Jupiter has over 3 times the mass of Saturn, it's actually not that much larger in radius. They're actually very comparable in size. The reason for this is because of what they're made of. Hydrogen and helium are very compressible. Specifically, any gas is very compressible. So as we add more hydrogen or helium, the bottom layers get compressed a lot, and so we don't actually add that much height to the planet. So Jupiter and Saturn are actually very similar in size. The densities of Uranus and Neptune are very similar to what we saw for Jupiter and Saturn. Uranus is around 1,240, Neptune is around 1,670. Now, although that seems, of course, they're gas giants, remember these have significantly less mass than either Saturn or Jupiter, which means they don't have as much gravity compressing everything in. So that suggests that, yeah, they do have some hydrogen and helium, but they should also have some other heavier materials inside. We'll discuss more about that in a bit. Based off of flybys and other observations, we see that Jupiter, the composition of Jupiter, or at least the surface, what we can actually see, is about 75% hydrogen, 24% helium, and 1% everything else. Saturn is about 92% hydrogen, 6% helium, and 2% everything else. Now, Jupiter and Saturn formed at the same time, in the same way, in the same place, so we'd actually expect them to have the same composition, and yet we see that they don't. Our current best guess as to what's happening is that on Saturn, it is so far away from the sun that the outer atmosphere gets so cold that helium is able to condense and fall as rain. So this decreases the amount of helium in the upper atmosphere, the stuff that we can actually see and detect, and so we decrease the amount of helium, which therefore increases the percentage of hydrogen and everything else and metals that we see for it. Based off of the Voyager flybys, Uranus's atmosphere is about 83% hydrogen, 15% helium, and 2% methane. And Neptune is similar to Uranus at 79% hydrogen, 18% helium, and 3% methane. Just a really quick note, methane is actually not stinky. So any jokes you might be thinking of about, oh, Uranus is so stinky because of the methane, methane has no smell. However, we have found hydrogen sulfide on Uranus, and hydrogen sulfide is that nasty rotten egg smell. So go ahead and use that if you wish. Now, it's actually the methane that gives Uranus and Neptune the distinct color. Methane preferentially absorbs red light, which means, or at least longer wavelengths, which means it's the shorter wavelengths, the blues and purples, that then reflect, that actually bounce out. So it's the methane that gives Uranus and Neptune their bluish colors. All right, here's our second question. Why is Jupiter denser than Saturn? A, due to Jupiter's gravity, it has been much more compressed. B, Jupiter contains a higher amount of rock and metal. C, Saturn is hotter, so the gases have expanded. Or D, Jupiter's magnetic field has compressed the atmosphere. Go ahead and think about it, and we'll discuss in just a little bit. Alright, so the answer is A. Remember, Jupiter has about 3 times more mass than Saturn, which means that it has much higher gravity, and gravity is compressing all of that gas down to a greater extent. So because of that, it is going to have a higher density. The correct answer again is A.